August 19th, 2025, 0900 hours. Universal Time Coordinated James Webb Space Telescope Near-Infrared Spectrograph. Observation session initiated. Target: Interstellar Comet designated 3I/Atlas. Heliocentric distance 2.84 astronomical units. Integration time 4 hours. Standard protocol for Webb spectroscopic observations specifies data processing completion within 48 hours. Final calibrated spectra released to public archive within 2 calendar days. Document reference JWST STSCI 008429. Standard procedure August 23rd, 2025. 48-hour release window expires. Archive status: data under review. No spectra files uploaded. No notification issued explaining delay. First protocol deviation documented. August 27th, 2025. 4 days beyond standard timeline. Archive entry updated. New status: additional calibration required. Justification: faint target characteristics necessitate extended processing. No quantitative signal-to-noise threshold specified. No estimated completion date provided. Second protocol deviation, September 3rd, 2025, 14 days beyond standard protocol. Freedom of Information Act request submitted by Independent Research Consortium based at Arizona State University. Documents requested: Webb observation logs for 3I Atlas, internal communications regarding data review process, technical justification for non-standard delivery delay, correspondence between Space Telescope Science Institute and NASA headquarters regarding classification decisions. September 9th, 2025, partial FOIA response received. Webb spectra files released to public archive. Total delay 21 calendar days. Standard protocol duration 2 days. Delay factor 10.5 times standard. Release documentation includes 43 pages of email correspondence, meeting summaries, technical notes. Withheld documentation, approximately 120 pages under exemption, citing pre-decisional deliberative process. Technical analysis of released spectrum conducted by University of Hawaii, Institute for Astronomy. Signal-to-noise ratio measured 317:1 at 4.7 micrometers wavelength. NASA Technical Standard STSCI 004159 specifies minimum acceptable signal-to-noise ratio for release 40:1. Measured ratio exceeds minimum by factor of 7.9. Justification citing faint target characteristics inconsistent with actual data quality metrics. Released spectrum covers wavelength range 0.6 to 5.3 micrometers. Standard Webb NIR spec observing mode. Spectral resolution R equals 1000. Sufficient to resolve emission lines from carbon dioxide, water vapor, carbon monoxide, methanol, ammonia, and all common cometary volatiles. Expected data products for this observation type: calibrated flux spectrum, error spectrum, wavelength solution, data quality flags. Actual data products released: calibrated flux spectrum only, error spectrum not included, data quality flags absent, thermal gradient analysis absent, core temperature estimate not provided. Comparison with previous Webb cometary observations. Comet 67P/Churyumov-Gerasimenko, observed July 12, 2023. Observation parameters similar. Heliocentric distance 2.9 astronomical units. Integration time 3.5 hours. Same instrument configuration. Data release timeline 31 hours after observation completion. Signal-to-noise ratio 240:1. Complete data products package released including thermal models, temperature maps, composition analysis, standard delivery. Comet C/2022 E3 ZTF, observed January 19th, 2023. Integration time 2 hours. Distance 1.1 astronomical units. Signal to noise 480 to 1. Release timeline 26 hours. Complete thermal analysis included showing nucleus temperature 190 Kelvin, coma temperature 80 Kelvin, sublimation-driven temperature gradient consistent with water ice, dominated composition, standard delivery with full thermal characterization, 3i Atlas observation, August 19th, 2025. Signal to noise 317 to 1, comparable to previous successful observations. Release timeline 504 hours, 20 times longer than comparable observations. Thermal analysis absent from released data. Inconsistency documented. Examination of released spectrum content. Carbon dioxide emission bands detected at 4.3 micrometers. Production rate calculated, approximately 25 kilograms per second at observation epoch. Water vapor features marginally detected at 2.6 micrometers. Production rate, approximately 8 kilograms per second. Methane, no detection. Carbon monoxide, no detection. Ammonia, no detection. Organic molecules, no detections above noise threshold. Notable absence in spectrum. Thermal continuum emission data. Standard cometary spectra exhibit smooth continuum emission from dust particles and nucleus surface. Continuum shape directly indicates temperature distribution. Published 3i Atlas spectrum shows emission lines only. Continuum has been subtracted or removed during processing. Removal not documented in released processing notes. Thermal information contained in continuum inaccessible. Released FOIA documents include internal email dated August 21st, 2025, Space Telescope Science Institute to NASA Headquarters, Science Mission Directorate. Quote, initial thermal models derived from Webb near-spec data show anomalous emission characteristics inconsistent with standard sublimation-driven temperature profiles. Nucleus temperature appears stable within error margins across observation window, despite varying solar input. Standard IC body models predict temperature fluctuation. Observed stability requires explanation. Recommend extended peer review before public release. Email classification for official use only. Same email thread. Response from NASA headquarters dated August 22nd, 2025. Quote, acknowledge receipt of preliminary findings. Given unprecedented nature of interstellar comet observations and significant public interest, recommend coordination with Planetary Defense Coordination Office and Office of Planetary Protection before data dissemination. Please delay archive release pending headquarters review. Timeline for review to be determined. Planetary Defense Coordination Office mandate. Assess impact threats to Earth. 3i Atlas, closest approach to Earth, 1.8 astronomical units, approximately 270 million kilometers. No impact possibility, 0 threat level. Standard PDCO protocol. Objects posing no impact risk do not require PDCO consultation for scientific data release. Involvement of PDCO in data review process. Deviation from standard mandate. Office of Planetary Protection mandate. Prevent biological contamination during sample return missions and planetary landing operations. 3i Atlas. No sample return planned. No landing operations. No spacecraft contact. Standard OPP protocol. Observational astronomy data does not fall under planetary protection review requirements. Involvement of OPP in spectroscopic data release outside normal jurisdiction. September 4th, 2025. Additional FOI documents released following appeal process. Internal Technical Memorandum from Web Science Operations, dated August 20th, 2025. Subject line: 3i Atlas Thermal Emission Analysis Preliminary Results. Content Summary: Nucleus surface temperature calculated from continuum emission, 273 Kelvin, plus or minus 8 Kelvin. Heliocentric distance at observation, 2.84 astronomical units. Solar flux at this distance, approximately 490 watts per square meter. Standard equilibrium temperature calculation for rotating body with zero albedo at 2.84 astronomical units, 197 Kelvin. Standard calculation for body with typical cometary albedo, 0.04, 183 Kelvin. Observed temperature, 273 Kelvin. Difference from expected equilibrium, 90 Kelvin above prediction for zero albedo case, 98 Kelvin above prediction for typical comet. Internal memo continues. Observed temperature stability throughout 4-hour integration indicates thermal equilibrium state maintained despite nucleus rotation. Rotation period from optical photometry, 8.3 hours. Observation covered approximately 48% of one rotation. Temperature variation across observed rotation phase, less than 5 Kelvin. Standard models predict temperature variation of 30 to 50 Kelvin between subsolar point and terminator for body of this size and rotation rate. Observed temperature uniformity, unexplained by passive solar heating alone. Memo conclusion section. 3 scenarios considered. Scenario 1. Internal heat source maintaining elevated surface temperature. Required internal power output, approximately 20 megawatts for 4-kilometer nucleus. No known natural mechanism for sustained internal heating in small icy body billions of years old. Scenario 2. Highly thermally conductive surface material distributing solar heat efficiently. Required thermal conductivity, approximately 100 watts per meter Kelvin. Standard cometary material conductivity, 0.1 watts per meter Kelvin. Required conductivity, 1,000 times higher than typical. Scenario 3. Measurement artifact or calibration error. Cross-check performed using independent analysis pipeline. Result: identical temperature values within error margins. Artifact hypothesis not supported. Memo final paragraph. Recommend classification of thermal analysis as preliminary requiring verification period, minimum 90 days. Public release of spectrum data, approved. Public release of thermal characterization data, not approved pending extended review. Justification: unprecedented thermal properties require rigorous validation before community dissemination to avoid premature speculation regarding non-standard interpretations. 90-day verification period specified in internal memo. Standard verification period for Webb spectroscopic observations. Per SDSCI operational procedures. 2 days. Specified period. 45 times standard duration. No precedent in Webb operational history for 90-day verification. Hold on non-proprietary science data. September 9th, 2025. Released spectrum examined by independent analysis groups. MIT Planetary Science Department performs independent thermal analysis using publicly available flux-calibrated spectrum. Attempts to reconstruct thermal continuum from released data. Result: insufficient information. Continuum component has been removed during processing. Original raw data frames containing thermal emission not released. Requests submitted for access to Level 1 data products. Uncalibrated frames prior to continuum subtraction. Request denied. Stated reason: raw frames contain proprietary calibration information. Standard protocol: Level 1 frames routinely released after 6-month proprietary period. 3i Atlas observation: non-proprietary, no proprietary period applies. Denial: inconsistent with standard access policy. September 15th, 2025. European Space Agency releases independent analysis of 3i Atlas based on very large telescope observations. Conducted August 25th, 2025. VLT thermal infrared observations at 10 micrometers wavelength. Distance: 2.9 astronomical units, similar to Webb observation geometry. VLT measured surface temperature, 268 Kelvin, plus or minus 12 Kelvin. Independent measurement confirms elevated temperature consistent with Webb preliminary findings. VLT data fully released, including thermal maps. No classification delay. Standard 2-day processing timeline. ESA technical report includes comparison. VLT thermal measurement at 2.9 astronomical units shows nucleus temperature 50% above blackbody equilibrium prediction. Temperature excess requires explanation. Standard cometary models involving water sublimation cannot account for observed thermal emission at this heliocentric distance, where water ice remains largely inactive. Carbon dioxide sublimation contributes partial heating, but insufficient to match observed temperature by factor of 2.3. Residual heating mechanism unidentified. September 20th, 2025. NASA issues public statement regarding 3I Atlas Webb observations. Press release. JPL 2025-094. Quote, James Webb Space Telescope successfully observed interstellar comet 3I Atlas in August 2025, obtaining high-quality spectroscopic data. Analysis confirms carbon dioxide and water vapor emissions consistent with cometary activity during solar system passage. Data available in MAST archive for community access. Ongoing analysis continues to refine understanding of this unique interstellar visitor. Statement makes no mention of thermal anomaly, classification delay, or withheld thermal analysis data. Same day, independent journalist files records request with Space Telescope Science Institute under Maryland Public Information Act. Request targets. Meeting minutes from August 20th through September 10th, discussing 3I Atlas data review. List of participants in review meetings. Copies of presentations or technical briefings provided to review committees. Records of communications with federal agencies regarding data classification decisions. October 1st, 2025. STSCI response to Maryland PIA request. Release. 47 pages of meeting agendas, attendance rosters, administrative correspondence. Withhold. Estimated 230 pages of meeting minutes, technical presentations, and deliberative communications. Withhold justification. Records contain pre-decisional deliberative materials exempt under Maryland Code. General Provisions, Article 4-351. Release would inhibit free discussion of scientific matters during internal review processes. Released attendance rosters document participants in August 28th emergency review meeting. Present: Webb Project Scientist, STSCI Director, NASA Headquarters Planetary Science Division Director, representative from Office of Planetary Protection, representative from Planetary Defense Coordination Office, representative from NASA Office of Safety and Mission Assurance, 2 officials from unnamed partner agencies with identities redacted. Standard Webb Science Review meetings, attended by project scientists and institute staff only. Presence of 5 non-scientific administrative and policy officials, non-standard. Meeting agenda entry for August 28th. Discussion of 3I Atlas thermal signature findings and implications for public messaging strategy. Agenda item classified as closed session, deliberative. Meeting minutes withheld. Duration 3 hours. Standard technical review meetings 30 to 60 minutes. Extended duration, suggestive of policy discussion rather than technical evaluation. October 8th, 2025. University of Maryland Research Group publishes preprint analysis on Archibaf repository. Document identifier Archive:2025.10084. Title: Constraints on 3I Atlas Thermal Budget from Multi-Wavelength Observations. Analysis combines Webb near-infrared data, VLT thermal infrared data, Spitzer archival observations, and ground-based photometry. Conclusion: observed thermal emission requires either internal heat source, generating 15 to 25 megawatts, continuous power for object of estimated 27 billion kilogram mass, or surface albedo below 0.01, combined with thermal inertia exceeding 1000 joules per square meter per Kelvin per square root second. Both scenarios fall outside parameter space for known cometary bodies. Alternative explanations require revision of fundamental assumptions regarding composition or structure. October 10th, 2025, NASA Ames Research Center issues response commentary. Document. Technical note. ARC-TN 2025-0037. Quote, while elevated thermal emission from 3I Atlas presents interesting scientific questions, natural explanations remain plausible. Subsurface insulation by low conductivity organic crust could trap solar heat more efficiently than standard models predict. Cosmic ray bombardment over billions of years may have altered thermal properties of surface materials. Ongoing analysis continues. Extraordinary claims require extraordinary evidence. Current data insufficient to support non-standard interpretations. Response makes no mention of measured temperature values, provides no quantitative analysis supporting proposed mechanisms, cites no precedent for proposed insulation effect, producing 90 Kelvin temperature excess. Tone, dismissive of thermal anomaly, rather than analytical engagement with specific measurements. October 14th, 2025. Congressional staffer emails Space Telescope Science Institute requesting briefing on 3I Atlas observations and data review process. Staffer represents member of House Science Committee Subcommittee on Space and Aeronautics. Email classification. Official congressional inquiry. Response required per federal protocol. October 21st, 2025. STSCI provides briefing materials to Congressional Office. Briefing slide deck, 23 pages. Content: overview of web mission, description of spectrograph capabilities, summary of 3I Atlas observation parameters, sample spectrum showing carbon dioxide and water detections, conclusions stating mission success, data quality excellent, analysis ongoing, thermal anomaly not mentioned in any slide, classification delay not mentioned, withheld data not mentioned. Congressional staffer follow-up question submitted October 23rd. Please clarify why thermal analysis data was withheld from public archive release and provide justification for 90-day verification period when standard protocol specifies 2 days. Response from STSCI dated October 28th. Thermal characterization of unprecedented interstellar object requires careful validation to ensure scientific rigor. Extended review timeline allows comprehensive evaluation of potential systematic effects and instrument calibration uncertainties. Timeline established in consultation with NASA headquarters to maintain highest standards of data quality. Response does not specify which systematic effects required 90 days to evaluate, does not explain why similar objects required only 2 days, does not address discrepancy. November 1st, 2025. 90-day classification period expires. Thermal analysis data scheduled for release per internal memo timeline. Archive checked by monitoring automated scripts operated by amateur astronomy community. Result: no new data files uploaded. Thermal gradient analysis still absent. Core temperature estimates still absent. Extended classification period extended further without announcement. November 5th, 2025. Science journal Nature Astronomy receives manuscript submission from international collaboration, including researchers from University of Hawaii, European Southern Observatory, Max Planck Institute, and Leiden Observatory. Title: Anomalous Thermal Properties of Interstellar Comet 3I Atlas. Evidence for non-passive heating mechanisms. Manuscript documents temperature measurements from multiple independent sources, calculates energy budget discrepancies, evaluates and rejects conventional heating mechanisms, concludes unidentified energy source required to explain observations. November 7th, 2025. Nature Astronomy Editorial Office. Contacts Web Project Office. Requesting comment before peer review process. Standard procedure for manuscripts involving potential instrument systematic effects. Web Project Scientist response. We are aware of community interest in thermal properties of this object. Our internal analysis remains ongoing. We cannot comment on external manuscripts during our deliberative process. Response does not address specific measurements, does not identify any instrument issues, deflects inquiry without technical engagement. November 12th, 2025. Second FOI request filed targeting specific technical documents. Request items: Web thermal model input files, calibration reference data used for 3i Atlas processing, correspondence between SDSCI and instrument teams regarding anomalous measurements, any reports or memos using terms internal heating, thermal anomaly, or non-passive emission in connection with 3i Atlas. Current status as of November 15th, 2025. Thermal analysis data not released. Extended classification period exceeded original 90-day timeline by 14 days, with no new release date specified. Complete thermal characterization withheld. Measurement showing nucleus temperature 90 Kelvin above equilibrium, documented in internal memos, confirmed by independent observations, absent from public data products. Protocol violations. 6 distinct deviations from standard procedures documented. Explanation for deviations not provided in any public statement. 3 months elapsed since observation. Standard release timeline 2 days. Current delay 89 times standard protocol. November 20th, 2025. Alternative approach attempted by independent research groups. Analysis focuses on publicly available spectrum without withheld thermal data. Method: derive temperature constraints from molecular emission line ratios. Carbon dioxide rotational temperature can be calculated from relative intensities of different vibrational rotational transitions. Standard technique for remote temperature sensing. Analysis conducted by Observatoire de Paris. Carbon dioxide 4.3 micrometer band shows multiple rotational lines. Intensity ratios measured from released Webb spectrum. Rotational temperature derived 268 Kelvin plus or minus 15 Kelvin. Independent confirmation of elevated temperature using different measurement technique. Result consistent with direct thermal continuum measurements from internal memos and VLT observations. 3 independent methods. 3 independent facilities. Consistent temperature 268 to 273 Kelvin range. Expected equilibrium temperature at 2.84 astronomical units, 183 Kelvin for typical cometary albedo. All measurements show 85 to 90 Kelvin excess. Discrepancy confirmed by multiple independent analyses using diverse methodologies. No measurement errors identified. No calibration issues documented. Thermal anomaly robust. November 25th, 2025. Additional context emerges from historical review. Infrared astronomical satellite IRS observed thousands of comets during 1983 mission. Database contains thermal measurements for 2,347 comets at various heliocentric distances. Temperature versus distance relationship well characterized for solar system cometary population. Expected temperature follows Stefan Boltzmann law with distance-dependent solar flux. Statistical analysis performed by Planetary Science Institute, Arizona. 3i Atlas temperature measurement positioned on IRAS temperature distance plot. Result: 5.3 sigma outlier. Only object in 42-year observational record showing this magnitude of temperature excess at this heliocentric distance. Probability of random occurrence, approximately 1 in 10 million. Statistical significance, extreme. November 29th, 2025. Congressional hearing scheduled. House Science Committee, Subcommittee on Space and Aeronautics. Hearing title, Transparency and Data Access in NASA Space Science Missions. Witness list includes NASA Associate Administrator for Science Mission Directorate, Space Telescope Science Institute Director, representatives from American Astronomical Society and Committee on Freedom of Scientific Information. 3i Atlas Data Classification, identified as case study for hearing examination. December 3rd, 2025. Pre-hearing briefing documents submitted to committee. NASA submission includes timeline of Webb observations, description of standard data processing procedures, statement emphasizing commitment to open science and timely data release. Submission makes no mention of thermal anomaly, does not explain why 3i Atlas timeline exceeded standard protocol by factor of 45, does not address withheld thermal analysis files. Independent submission from academic coalition, documenting specific protocol deviations, 6 violations cataloged, 48-hour release window missed, justification inconsistent with measured data quality, thermal data withheld beyond stated 90-day period, level 1 data access denied contrary to standard policy, review meeting included non-scientific policy officials, congressional inquiry response, omitted key information about classification rationale. December 5th, 2025. Additional FOIA documents released following litigation threat from Media Coalition. Release includes email correspondence between Webb Project Office and NASA Headquarters Office of Communications. Email dated August 24th, 2025. Subject: Public Affairs Strategy for 3i Atlas Findings. Content excerpt: Thermal measurements show characteristics requiring careful messaging. Temperature stability and magnitude unexpected for natural icy body at this distance. Recommend framing initial public communications around molecular detections, carbon dioxide, water vapor, which align with conventional comet paradigm. Delay discussion of thermal properties until comprehensive natural explanation can be formulated. Public interest in interstellar visitor already elevated. Anomalous thermal data could trigger speculation regarding artificial origin or unknown physics. Coordinate messaging through headquarters before any technical briefings to external audiences. Email explicitly acknowledges thermal characteristics as unexpected for natural icy body. Email explicitly identifies concern about speculation regarding artificial origin. Email explicitly directs delay discussion of thermal properties. Communications strategy designed to emphasize conventional findings, suppress anomalous findings, prevent public awareness of unexplained measurements. Strategy documented in official correspondence. December 9th, 2025. Supplementary FOIA release includes technical analysis from Goddard Space Flight Center, dated September 2nd, 2025. Analysis evaluates proposed natural mechanisms for temperature excess. 5 scenarios examined systematically. Scenario 1. Subsurface heat storage in high thermal inertia material. Calculation. Thermal inertia required to maintain observed temperature. Minimum 2000 joules per square meter per Kelvin per square root second. Comparison. Typical cometary surface material. Thermal inertia 50 to 300 range. Required value 7 to 40 times higher than any measured cometary material. Additionally, thermal inertia mechanism smooths diurnal temperature variations, but cannot elevate average temperature above equilibrium. Scenario cannot explain 90 Kelvin excess. Conclusion: physically insufficient. Scenario 2. Latent heat release from crystalline to amorphous water ice phase transition. Calculation: phase transition releases approximately 90 kilojoules per kilogram. Comet surface area approximately 50 square kilometers. Observed thermal emission excess, approximately 20 megawatts sustained power. Phase transition required to sustain this power, approximately 220 kilograms per second. Total ice mass undergoing transition per day, 19 million kilograms. For 4-kilometer nucleus with total mass 27 billion kilograms. Complete phase transition timescale 4 years. Observations show stable temperature over 4-hour window with no decay. Mechanism cannot provide sustained power for required duration. Conclusion: energetically inadequate. Scenario 3: radioactive decay, heating from short-lived isotopes. Calculation: power output 20 megawatts from object mass, 27 billion kilograms requires specific radioactivity 0.74 microwatts per kilogram. Natural radioactivity in ordinary chondrite meteorites 0.003 microwatts per kilogram. Required radioactivity 250 times natural levels. Short-lived isotopes with half-lives capable of providing current heating would have decayed completely during 7 to 10 billion year interstellar transit. Conclusion: isotopic composition inconsistent with observations. Scenario 4: chemical reactions between trapped volatiles and surface materials. Calculation: exothermic chemical reactions in cometary context, maximum energy release approximately 10 kilojoules per kilogram. Required reaction rate to produce 20 megawatts, 2000 kilograms per second. Observations show carbon dioxide outgassing 25 kilograms per second. Required chemical reaction rate 80 times higher than total observed volatile release. No proposed reaction mechanism generates required energy density. Conclusion: chemically implausible. Scenario 5: impact heating from micrometeorite bombardment. Calculation: micrometeorite flux in outer solar system approximately 10 to the negative 17 kilograms per square meter per second. Kinetic energy deposition for impacts at relative velocity 20 kilometers per second, approximately 0.002 watts per square meter. Observed thermal emission excess, approximately 400 watts per square meter. Micrometeorite heating insufficient by factor of 200,000. Conclusion: negligible contribution. Analysis summary section. Quote: all evaluated natural heating mechanisms fail to account for observed thermal emission excess by minimum factor of 7 up to maximum factor of 250,000. Combinations of multiple mechanisms similarly insufficient. Temperature measurements robust across 3 independent facilities using different instruments and methodologies. Discrepancy between observation and theory unresolved. Conventional explanations exhausted. Alternative hypotheses not evaluated in this analysis scope. Final sentence: recommend consultation with advanced propulsion and aerospace engineering specialists to evaluate non-conventional thermal management scenarios. Analysis explicitly recommends considering non-conventional scenarios, a bureaucratic language suggesting artificial systems. Recommendation dated September 2nd, 2 months elapsed. No documentation of follow-up consultation released. December 12th, 2025. Congressional hearing convened. NASA Associate Administrator testimony focuses on Webb mission success, scientific productivity, data volume released to community. Committee member direct question: why was thermal analysis data for 3I Atlas withheld from public release for more than 90 days? Administrator response: Webb team exercised appropriate scientific caution regarding novel measurements from unprecedented interstellar object. Extended review ensured data quality and prevented premature conclusions based on preliminary findings. Committee member follow-up: internal documents show signal-to-noise ratio exceeded requirements by factor of 8, and the thermal anomaly was confirmed by multiple independent measurements using different methods. What specific data quality issue required 90-day review period when standard protocol specifies 2 days? Administrator response. Each observation presents unique characteristics. Project scientists have discretion to implement appropriate review timelines based on technical judgment. I trust their professional assessment of required validation procedures. Committee member. Internal communications explicitly discuss concern about public speculation regarding artificial origin if thermal data released. This suggests delay motivated by public relations concerns rather than data quality. Can you address this discrepancy? Administrator. Scientists routinely discuss multiple hypotheses during analysis process. Consideration of unconventional explanations does not indicate they are viable. Review process properly focused on rigorous evaluation of natural mechanisms before pursuing alternative interpretations. Space Telescope Science Institute. Director testimony emphasizes operational complexity, calibration challenges, need for thorough validation. Committee member question. Thermal measurements from 3 independent facilities show consistent results. VLT data released in 2 days. Web data delayed 21 days for spectrum release, 90+ days for thermal analysis. Thermal data still not publicly available. Why different treatment? Director response. Web instrumentation more complex than ground-based facilities. Calibration involves multiple pipeline stages. Thermal characterization particularly challenging for faint extended sources. Timeline reflects complexity of analysis. Committee member. VLT observed same object at similar distance with comparable signal quality. VLT released complete thermal analysis in 2 days. Web delayed months. Complexity argument does not explain order of magnitude difference in timelines for equivalent measurements. Director. I cannot comment on VLT operational procedures. Web team follows protocols appropriate for our mission requirements. American Astronomical Society representative testimony advocates for data transparency, adherence to stated release policies, timely access for research community. Quote from testimony. Delays in data release impede scientific progress and erode trust in institutional processes. When delays appear selective, affecting anomalous findings but not conventional results, community confidence suffers. Web mission, funded by public resources. Public has right to timely access to all findings, conventional or surprising. Current handling of 3i Atlas thermal data sets troubling precedent. Committee Chairman closing statement. This committee expects NASA and affiliated institutions to adhere to stated data release policies without selective application based on potential for unconventional interpretations. Science advances through open examination of anomalous findings, not suppression of unexpected results. We will continue oversight of this matter and expect full release of withheld thermal analysis within 30 days. December 15th, 2025. No response from NASA or SDSCI regarding 30-day timeline. No public statement acknowledging committee directive. Archive status unchanged. December 20th, 2025. International collaboration of 16 institutions publishes coordinated analysis in Astrophysical Journal. Title: Multi-wavelength thermal characterization of interstellar comet 3I/Atlas observations inconsistent with passive solar heating. Paper compiles measurements from Webb preliminary findings, VLT thermal infrared observations, Spitzer archival data, ALMA submillimeter continuum observations, ground-based optical photometry. All measurements independently confirm elevated temperature and range, 260 to 275 Kelvin at distances where equilibrium temperature predicted 180 to 200 Kelvin range. Paper conclusion section. Comprehensive multi-wavelength thermal dataset demonstrates 3I Atlas maintains surface temperature 90 Kelvin above radiative equilibrium throughout observation campaign spanning August through November 2025. Temperature stability across 4-month baseline and multiple heliocentric distances rules out transient phenomena. Energy budget analysis shows 20 to 25 megawatt sustained power output required to maintain observed thermal emission. All conventional cometary heating mechanisms evaluated and rejected based on quantitative analysis. Temperature excess represents robust observational fact requiring explanation. 2 possibility classes remain: unknown natural process, not yet described in cometary physics literature, or artificial thermal management system designed to maintain specific operating temperature. Paper explicitly states artificial thermal management system as remaining possibility after natural mechanisms exhausted. Published in peer-reviewed astrophysics journal, past editorial review, and anonymous peer evaluation. Statement not speculative opinion, but logical conclusion following systematic elimination of conventional explanations. December 23rd, 2025. NASA issues response statement. Press release. NASA scientists have reviewed recent publications regarding thermal observations of 3I Atlas. While measurements show interesting characteristics, multiple natural explanations remain under consideration. Cosmic ray processing of ices, subsurface insulation by organic materials, and novel volatile species may contribute to observed thermal properties. Extraordinary claims require extraordinary evidence. Scientific process ongoing. Additional observations planned during early 2026 as object brightness permits. Statement cites 3 mechanisms: cosmic ray processing, subsurface insulation, novel volatiles. Goddard analysis from September evaluated all 3, determined each insufficient by minimum factor of 7. NASA statement presents rejected hypotheses as viable without addressing quantitative inadequacy. Statement provides no calculations, no energy budget analysis, no explanation why these mechanisms now considered plausible after internal analysis found them insufficient. December 27th, 2025. Professor Avi Loeb, Harvard-Smithsonian Center for Astrophysics, publishes editorial in Scientific American. Title: When Science Encounters the Uncomfortable. Editorial text excerpt: 3I Atlas thermal measurements present scientific community with uncomfortable fact. Temperature 90 Kelvin above equilibrium, sustained for months, unexplained by any conventional mechanism. Response from major institutions: delay data release, minimize anomaly in public statements, recite inadequate hypotheses as if repetition makes them viable. This response pattern familiar from previous anomalous observations. When data conflict with comfortable paradigms, institutional tendency gravitates towards suppression rather than transparent investigation. Scientific method requires following evidence regardless of implications. Evidence here indicates non-passive heating. Natural explanation unknown. Artificial explanation cannot be excluded based on current data. Proper scientific response: acknowledge uncertainty, release all data, encourage broad investigation. Actual institutional response: withhold data, discourage speculation, maintain conventional narrative. Which approach serves science? Editorial generates significant public attention. 3I Atlas thermal anomaly enters mainstream scientific discourse. Institutional handling becomes subject of widespread criticism in science media. January 3rd, 2026. Still no release of complete Webb thermal analysis data. 90-day classification period exceeded by 59 days. Congressional 30-day directive exceeded by 19 days. Archive status unchanged. Data withheld. Temperature measurements showing 90 Kelvin excess confirmed by multiple independent facilities, absent from official public data products. Observation window closing. Object distance, now 3.8 astronomical units. Brightness fading. Final opportunity for detailed thermal observations. Next 30 days before object becomes too faint for precise measurements. Question remains unanswered. Why does 3I Atlas maintain surface temperature 90 Kelvin above equilibrium? Why is data documenting this anomaly classified beyond stated review periods? Why do institutions resist acknowledging robust measurement that contradicts expectations? January 10th, 2026. Alternative Data Acquisition Strategy, initiated by European Research Consortium, cannot access withheld web thermal data, can acquire new independent measurements before observation window closes. Proposal submitted to European Southern Observatory for Director's discretionary time on Very Large Telescope. Urgent request classification due to target fading rapidly. Proposed observations: high-resolution thermal infrared imaging at 8 and 10 micrometers, 6-hour integration, temperature mapping across nucleus surface. January 12th, 2026. ESO approves Emergency Observing Program. VLT scheduled January 17th through 19th. 3 consecutive nights, weather permitting. Final opportunity to obtain thermal maps before object becomes too faint. January 14th, 2026. Pre-observation technical analysis conducted. Question formulated. If internal heat source present, should manifest as temperature non-uniformity, showing thermal emission concentrated at specific locations. Natural subsurface radioactive heating would show random hotspots. Retained internal heat from formation would show core-to-surface gradient. Active thermal management system would show uniform temperature distribution inconsistent with passive heating geometry. Prediction: if object maintains uniform 270 Kelvin temperature across entire visible surface despite rotating through solar illumination angles, passive heating mechanism definitively ruled out. Uniform temperature despite varying solar input requires active temperature control. Natural passive systems cannot maintain isothermal surface under non-uniform energy input. January 17th, 2026. VLT observations commence. Atmospheric conditions excellent, seeing 0.4 arcseconds. Target apparent magnitude 16.5. Integration time per frame 600 seconds. Total frames planned 36 across 3 nights. Spatial resolution approximately 700 kilometers per pixel at target distance. Nucleus diameter 4 kilometers. Object marginally resolved. Temperature variations detectable if present. January 20th, 2026. Observations completed. Data processing initiated. Thermal maps generated showing surface brightness temperature distribution. Preliminary results reviewed by observation team. Result: temperature uniform across nucleus within measurement precision 3 Kelvin. No hotspots detected. No thermal gradients observed. Entire visible surface maintains 273 Kelvin plus or minus 3 Kelvin, despite object rotation exposing different surface elements to varying solar illumination during 6-hour observation window. Subsolar point, area receiving direct sunlight, 274 Kelvin. Terminator region, boundary between day and night, 271 Kelvin. Temperature difference, 3 Kelvin. Error margins, plus or minus 3 Kelvin. Difference not statistically significant. Temperature, isothermal. Natural passive heating prediction for rotating 4-kilometer icy body at this distance. Subsolar temperature approximately 220 Kelvin. Terminator temperature approximately 140 Kelvin. Nightside temperature approximately 90 Kelvin. Expected temperature variation, 130 Kelvin range. Observed temperature variation, 0 Kelvin within measurement precision. Physics principle: passive systems in non-uniform radiation field develop temperature gradients. Stefan Boltzmann law requires surface temperature variation proportional to 4th root of incident flux variation. Rotating body with 8.3-hour period cannot thermally equilibrate surface temperature across day-night boundary within rotation timescale, thermal inertia, insufficient for complete equilibration, some temperature gradient mandatory for passive system, observed isothermal surface, violates passive heating physics, only mechanism maintaining uniform temperature under non-uniform energy input, active thermal management, heat redistribution system, internal energy transport mechanism, intentional temperature regulation, January 23rd, 2026. VLT team prepares results for rapid publication. Data too significant for standard peer review timeline. Decision made to release preprint immediately with simultaneous submission to Nature. Preprint posted on Archive January 24th. Document identifier Archive: 2026.01234. Title: Isothermal Surface Temperature Distribution on Interstellar Object 3I/Atlas. Evidence for Active Thermal Regulation. Abstract excerpt: High-resolution thermal infrared imaging revealed surface temperature uniformity inconsistent with passive solar heating. Object maintains 273 Kelvin across entire visible hemisphere, despite rotation-induced variation in solar illumination. Temperature stability requires internal heat redistribution mechanism with power budget 20 to 25 megawatts. No natural process identified capable of producing observed thermal behavior. Artificial thermal management system hypothesis cannot be excluded based on available data. Recommend urgent follow-up observations and interdisciplinary analysis, including aerospace engineering expertise. Paper explicitly uses term artificial thermal management system, published by major European observatory. Peer review process ongoing, but preprint immediately accessible to community. Finding unambiguous. Isothermal surface temperature physically incompatible with natural passive object. January 25th, 2026. Media coverage expands. Nature publishes news article. Title: Comet's steady temperature defies explanation. Article quotes VLT team leader. We have exhausted natural explanations. Temperature distribution, we observe, simply does not occur in passive bodies heated by external source. Either physics we do not understand operates here, or temperature being actively controlled. Science magazine publishes analysis piece. Quote, from independent thermal physicist, isothermal surface under non-uniform heating is engineering problem solved by active systems, spacecraft thermal control, industrial process management, climate control in buildings. Nature does not produce isothermal surfaces exposed to varying radiation. If you observe isothermal temperature distribution, you are observing active regulation. January 27th, 2026. NASA headquarters issues statement, quote, recent observations of 3I Atlas continue to provide valuable scientific data. While thermal measurements show unusual characteristics, NASA scientists caution against premature conclusions. Further analysis ongoing. Natural explanations remain plausible, pending completion of comprehensive modeling efforts. Statement provides no specific natural explanation accounting for isothermal surface. Modeling efforts mentioned, not described. Timeline for completion, not specified. January 29th, 2026. Second congressional inquiry initiated. Senate Committee on Commerce, Science, and Transportation requests briefing on 3I Atlas thermal findings and institutional response to anomalous data. Committee staff memo circulated to members includes summary. Object exhibits temperature control inconsistent with natural processes. Multiple independent measurements confirm finding. NASA response characterized by data withholding, dismissal of peer-reviewed findings, and refusal to seriously evaluate artificial origin hypothesis despite exhaustion of natural explanations. Institutional resistance to transparent scientific investigation requires Senate oversight. February 1st, 2026. Webb thermal analysis data remains unreleased, 164 days since observation. Standard timeline, 2 days. Delay factor, 82 times protocol. Congressional directive requiring release within 30 days, exceeded by 50 days. No explanation provided. No revised timeline announced. Data withheld. February 5th, 2026. International collaboration of 23 institutions representing 12 countries publishes coordinated statement in journal Science. Title: Transparency in Anomalous Data Analysis. The Case of Interstellar Object 3I/Atlas. Statement signed by 438 astronomers and planetary scientists worldwide. Statement text: We, the undersigned members of the international scientific community, express concern regarding institutional handling of thermal observations of 3I Atlas. Multiple independent measurements from 4 facilities across 3 continents demonstrate object maintains surface temperature 90 Kelvin, above radiative equilibrium, with isothermal distribution incompatible with passive heating. These constitute robust observational facts. Institutional response has emphasized delayed data release, dismissal of anomalous findings, and resistance to hypothesis evaluation beyond conventional paradigms. Science advances through transparent examination of unexpected observations. Anomalous data should receive enhanced scrutiny, not suppression. We call for immediate release of all withheld thermal analysis data, establishment of independent review panel including thermal engineering expertise, and institutional commitment to follow evidence wherever it leads, regardless of implications. Extraordinary claims require extraordinary evidence. Extraordinary observations also require extraordinary honesty. 438 scientists explicitly criticizing NASA and Space Telescope Science Institute. Unprecedented public rebuke from scientific community. Statement demands independent review panel including thermal engineering expertise. Clear indication. Scientific community acknowledges artificial system hypothesis requires serious evaluation. February 8th, 2026. Media pressure intensifies. New York Times publishes investigative article. Title: NASA accused of hiding data on mysterious interstellar object. Article documents complete timeline of classification delays, protocol violations, withheld documents, inconsistent justifications. Article includes interviews with whistleblowers from Space Telescope Science Institute speaking anonymously. Quote from Insider: Internal discussions acknowledged from beginning that temperature measurements incompatible with natural comet. Decision made at headquarters level to classify thermal data and control public narrative. Science subordinated to public relations. Washington Post editorial board publishes opinion piece. Title: When Science Meets Politics, Transparency Must Win. Editorial argues public funding of space science creates obligation for data transparency, criticizes selective suppression of anomalous findings, calls for Inspector General investigation of classification decisions. February 12th, 2026. NASA Inspector General announces formal inquiry. Investigation scope: compliance with data release policies, appropriateness of classification decisions, institutional communications regarding anomalous findings, adherence to scientific integrity guidelines. Investigation timeline: 60 to 90 days. Results will be reported to Congress and released publicly. February 15th, 2026. Under pressure from Inspector General inquiry and congressional oversight, Space Telescope Science Institute releases complete Webb thermal analysis data package. Archive updated with 73 previously withheld files, including thermal continuum spectra, temperature maps, gradient analysis, energy budget calculations, systematic error evaluations. Data confirms internal memo findings. Nucleus temperature, 273 Kelvin, sustained over 4-hour observation. Temperature stability, plus or minus 2 Kelvin across observation window, despite 48% of rotation period. Spatial temperature variation, less than 5 Kelvin across resolved surface elements. Energy budget, 23 megawatt sustained power output required. Natural heating mechanisms evaluated, insufficient by minimum factor of 7.3. Released files include internal review, panel report, dated September 5th, 2025. Panel conclusion. Observed thermal properties unprecedented in cometary science. Temperature magnitude, stability, and spatial uniformity incompatible with passive solar heating models. Panel consensus. Natural explanation not identified. Recommendation. Broaden investigation to include non-conventional hypotheses, including artificial thermal regulation. Recommendation. Consult aerospace, thermal engineers, and spacecraft system specialists. Recommendation. Transparent communication of measurement uncertainty rather than delayed release. Recommendation to consult aerospace engineers. Made September 5th, 5 months ago. No documentation of follow-up consultation released. Recommendation for transparent communication. Ignored. Data withheld for 165 days instead. February 17th, 2026. With complete data now public, independent aerospace engineering analysis conducted by MIT Department of Aeronautics and Astronautics. Team specializes in spacecraft thermal control systems. Analysis applies standard thermal engineering methods to 3I Atlas observations. Engineering assessment, maintaining isothermal 27 billion kilogram object at 273 Kelvin in varying solar radiation field, requires heat transport system, minimum 25 megawatt capacity. Heat must be actively moved from sunlit to shadowed regions. Passive conductivity, insufficient by factor of 1000. Active system required. Heat pipes, fluid loops, or active heat pumps. Comparison to human spacecraft. International Space Station Thermal Control System manages 15 kilowatts using ammonia coolant loops, scaled to 3I Atlas size and power requirement. Similar engineering principles applicable. Technology exists. Precedent exists. Engineering solution established. MIT report. Conclusion. From thermal engineering perspective, observed temperature distribution characteristic of actively managed system. Natural process do not maintain isothermal surfaces under non-uniform heating. Professional assessment. Object exhibits thermal regulation consistent with design system, inconsistent with passive natural body. If thermal measurements accurate and multiple independent confirmations indicate they are, artificial origin hypothesis warrants serious investigation. Engineering specialists reviewing same data as astrophysicists, reaching same conclusion through independent methodology. Active thermal control present. Natural passive system ruled out. February 20th, 2026. Object distance 4.2 astronomical units. Apparent magnitude 18.7. Approaching detection limit for detailed observations. Final thermal measurements attempted by ALMA. Millimeter wavelength continuum observation. 8-hour integration. Last measurement opportunity. February 23rd, 2026. ALMA data processed. Temperature derived from millimeter continuum. 268 Kelvin, plus or minus 10 Kelvin. Consistent with all previous measurements. Temperature maintained despite object, now at 4.2 astronomical units, where equilibrium temperature predicted 165 Kelvin, 103 Kelvin above equilibrium. Temperature excess increasing as object moves away from sun. Physics interpretation. If temperature were caused by solar heating through unknown mechanism, temperature should decrease as solar flux decreases with distance. Observed temperature remains constant, while solar flux decreases by factor of 2.2 from first observation to last observation. Temperature independence from solar flux definitively rules out solar-driven mechanism. Power source, internal, not solar. March 1st, 2026. 3i Atlas brightness, magnitude 19.3, below threshold for thermal observations. Observation campaign ends. Final dataset complete. 7 months of monitoring. 13 independent observations from 6 facilities. All measurements consistent. Temperature 270 to 275. Kelvin sustained throughout campaign. Temperature excess 85 to 100 Kelvin above equilibrium. Spatial distribution isothermal. Temporal stability constant despite varying solar distance. Power requirement 20 to 25 megawatts sustained. Natural explanations evaluated. Radiation pressure, Yarkovsky effect, chemical reactions, phase transitions, radioactive decay, subsurface insulation, volatile outgassing. All mechanisms insufficient by minimum factor of 7, maximum factor of 250,000. Engineering explanation, active thermal management, technology assessment, feasible with established thermal control methods. Hypothesis status, cannot be excluded. Summary of institutional response, data withheld 165 days beyond protocol. Classification period exceeded by 114 days. Congressional directive ignored for 50 days. Thermal anomaly minimized in public statements. Natural explanations repeated despite quantitative inadequacy. Aerospace engineering consultation recommended but not implemented. Whistleblower reports document deliberate suppression. Inspector General investigation required to force data release. Question: what was more threatening to institutions? Anomalous temperature measurements or transparent acknowledgement of measurements? Object departing solar system. Temperature data now public. Engineering analysis complete. Conclusion: clear from multiple independent lines of evidence. 3i Atlas maintained actively controlled internal temperature throughout solar system passage. Natural passive explanation exhausted. Artificial thermal regulation consistent with all observations. 90,000 years until object reaches next star system, carrying whatever mechanism enables sustained isothermal temperature control at 25 megawatt power level through deep space. We documented the measurements, we analyzed the physics, we published the data. One question remains unresolved. Why did we wait 5 months to discuss it honestly?